Hello friends, today I will discuss the numerical problems on tariff. First question is, a daily load of industry is 200 kilowatts for first 1 hour, 150 kilowatts for next 7 hours, 50 kilowatts for next 8 hours and 1 kilowatt for remaining period. If tariff is 100 rupees per kilowatt of maximum demand per annum plus 5 pice per kilowatt hour, find the annual bill. In this numerical, there are two things which are to be considered. So first of all, we should know what is kilowatt hour. That is 1 kilowatt hour is nothing but 1 unit. So written 1 unit or simply unit means that is 1 kilowatt hour. So next, rate of charge on maximum demand, that is also given. Similarly, rate of charge on energy consumed also given. Using these charges or tariffs, so separate bill has to be generated with respect to the maximum demand and with respect to the energy consumed after subtracting the energy consumed with respect to the maximum demand from the total energy consumed. Step 1 is, what is maximum demand in this load schedule. So look at this daily load means for 24 hours period, what are the loads on the system or in the industry. That is 200 kilowatts, 150 kilowatts, 50 kilowatts, 1 kilowatt. Out of these, 200 kilowatts is the maximum power that is taken by the industry. So this will be considered as maximum demand of the industry. So we write here maximum demand is 200 kilowatts. Next, step 2 is, what is the energy consumption per day. So we know here per the day for 24 hours how the energy is consumed in different periods of 24 hours. So first period is 1 hour and 200 kilowatts is consumed. So 200 kilowatts into number of hours, you will give the energy consumed in that period. Similarly, in the next 7 hours, the power consumed is 150 kilowatts. So multiplied with 7 hours will give the energy consumed in the next 7 hours. Next, in the next 8 hours, industry consuming 50 kilowatts power. So 50 kilowatts into 8 hours will give the energy consumed in that period. Next, remaining period is only 8 hours. So in that period 1 kilowatt power is used. So 1 kilowatt into number of hours, that is 8 hours, will give the energy consumed in this last 8 hours. So after simplification, we get like this: 200 plus 150 plus 400 plus 8, and total will become 1658 kilowatts hours. This is the total energy consumed per day, but he is asking the bill per annum. So for 360, so for 365 days, how much is the energy consumed? That is to be calculated as it demanding annual bill. So energy consumed per annum is equal to energy consumed per day into number of days in a year. So just now calculated the number of units or the kilowatt hours consumed in a day. So substitute here, that is 1658, and number of days in a year is nothing but 365. So multiplying these two will lead to 605170 kilowatt hours. This is the total energy consumed per annum. For this, bill has to be generated. So Step 4 is annual bill is, first the bill is to be generated with respect to the maximum demand, that is maximum demand in kilowatts into the rate of tariff with respect to the maximum demand plus annual energy consumption into tariff with respect to the annual energy consumption. So here for maximum demand the rate of charge is 100 rupees. So 100 rupees per kilowatt. So here it is 200. So 200 into 100 rupees. So that is the bill corresponding to the maximum demand energy. Next, with respect to the annual energy consumption, so just now calculated total energy consumed is 6,51,5,170. So multiplied with 0.05 rupees per unit. So this will give the bill corresponding to the annual energy consumption, whereas this is the bill corresponding to the maximum demand. So adding these, we get here 20,000 plus 30,258.5, and that lead to 50,258.5 rupees. So let me consider another problem, that is the maximum annual bill of a consumer whose maximum demand is 100 kilowatts. So let me consider the second problem, that is here find the annual bill of a consumer whose maximum demand is 100 kilowatts, power factor is 0.8 lagging and load factor is 60%. The tariff used is 75 rupees per KVA of maximum demand plus 15 pice per kilowatt hour consumed. So with respect to the previous problem, here the difference is the charges are done based on maximum demand which is in KVA. Earlier it was with respect to maximum demand in KW. So here first of all we should know what is 1 kilowatt hour, that is nothing but 1 unit energy. Next, step 1 is we should know what is power triangle. What is the necessity of this? To convert maximum demand which is in kilowatts into KVA. So from the power triangle we know this is the real power axis, this is the reactive power axis, and this is the apparent power axis. The units for real power is in kilowatts and reactive power is KVAR, and the apparent power units are KVA. So the charges are based on KVA. So we should write what is cos phi. Cos phi is nothing but real power divided by apparent power. From this apparent power we can calculate, that is S is equal to P by cos phi. Because the real power is known and cos phi is also given. So now it can be easily calculated what is maximum demand in KVA, that is S is equal to 100 divided by 0.8, that is nothing but 125 KVA. Next, step 2 is what is the KW consumed, WH consumed means energy consumed per annum. So we have the rates, so that is maximum demand into load factor into number of hours in a year. So in the step 2, first calculate what are the number of units consumed per annum with respect to the maximum demand. We know maximum demand in kilowatt uh, in KVA and the load factor into hours. But we use here maximum demand in KW only up to here. So maximum demand is 100 kilowatts into load factor is also given, so that is 60% means 0.6 into Number of hours in a year, that is 8760 hours. So after simplification we get 5.256 into 10 power 5 kilowatt hours. So next step is step 3. Find the annual bill. Annual bill is nothing but the maximum demand into rate of charges, that is tariff based on maximum demand plus energy consumption per annum into the tariff corresponding to the number of units consumed. So here what we found here is we calculated what are the number of units consumed per annum using the maximum demand, which is in kilowatts, and whereas while calculating the annual bill we have used the maximum demand in in KVA. So KVA already calculated, that is 125 KVA corresponding to maximum demand into the rate of charges or tariff corresponding to the maximum demand is given as 75 rupees per KVA, then plus total energy consumed per annum, that is also calculated as 5.256 into 10 power 5, and the rate of charge or tariff corresponding to the total number of units consumed is given as 15 pies per kilowatt hours. So after converting that into rupees we get here 0.15 rupees per unit. So multiplied with total number of units consumed will give this bill, and this is corresponding to the maximum demand in KVA. And so after simplification we get here 9375 is the bill corresponding to the maximum demand, whereas the total number of units consumed becomes 78,840, and after adding these two then we get here 88,215 rupees. So in this problem KW is used, maximum demand KW is used to calculate what are the number of units consumed per annum, and using the power triangle we used maximum demand converted into KVA, and the tariffs are used in the final equation, that is here. Next, third problem is the maximum demand of a consumer is to 25 amperes at 220 volts, and his total energy consumption is 9750 kilowatt hours. If energy is charged at the rate of 20 pies per kilowatt hour for 500 hours use of maximum demand plus 5 pies per unit for all additional units, estimate his annual bill and the equivalent flat rate per unit. Next, third problem. Here the data is given like this. So here there is a small twist. So he is giving the data that there is a rate of charge based on the maximum demand, and similarly from the total energy consumed, the energy consumed with respect to the maximum demand should be subtracted, and for that number of units consumed there is another tariff, that is 5 pies per unit, and these two bills should be added to get the what is called the annual bill, and after that what is the annual or flat rate per unit also should be calculated. So in this problem also we should know what is kilowatt hour, that is nothing but 1 unit, and energy consumed with respect to with maximum demand power for 500 hours. This is the first one which is to be calculated, and the tariff is based on the energy consumed due to the maximum demand is giving, so that has to be used. Earlier they used to give the rate of charge based on the maximum demand in kilowatts or maximum demand in KVA. Now it is not so. It is the energy consumed due to the maximum demand for so and so hours. So in this case it is 500 hours. So step 1 is find the maximum demand, and for this that is also not given directly, so we assume power factor is unity, but the voltage of the consumer is given and the current drawn also given. So once it is known, so we can calculate what is power or maximum demand is equal to VI cos phi. V is 220 volts, I is 25 amperes, cos phi is 1. So after substituting all these values, you will get 5500 watts. So that is nothing but 5.5 kilowatts. And this we call as maximum demand, that is 5.5 kilowatts. Next, step 2 is total energy consumed. This is already given, so that is nothing but 9750 units. And next, step 3 is total cost of energy generation is equal to number of units with respect to maximum demand into rate of charge with respect to maximum demand plus total units generated minus number of units with respect to maximum demand into rate of charge with respect to total units consumed. Now in step 3, total cost of energy generation is equal to number of units with respect to maximum demand into rate of charge with respect to maximum demand plus total number of units generated minus number of units with respect to maximum demand into a rate of charge with respect to total units consumed. So total cost of energy generation can be calculated like this: maximum demand into number of hours into 0.2 rupees per kilowatt hours. Here it is given there 20 pies. 20 pies converted into rupees is 0.2 rupees. So next, plus total units generated minus maximum demand into number of hours. Total units generated also given and maximum demand also calculated. So number of hours that is also given, that is 500 hours, and rate also given as 5 pies. 5 pies means 0.05 rupees. Substituting all these values available, so we get like this: 5.55 is the maximum demand, that is kilowatts, into number of hours used is 500. 5.5 into 500, that gives us kilowatt hours, into the rate of charge is also given as 20 pies means 0.2 rupees per kilowatt hour. So this bill corresponding to the maximum demand units. So next, so we know what is the total energy consumed, that is 9750 units. So in that, the number of units consumed based on maximum demand just now calculated here. So the same value has to be substituted, that is maximum demand into number of hours into 0.05, that is this. So substitute all the values. So then we get here 550 plus 9750 minus 5.5 into 500 into 0.05. Then in the next stage we get 550 plus 9750 minus 2750 into 0.05. So after subtraction here we get 7000, and this first term is 550. So then 7000 units into the rate is given 5 pies means 0.05. So after simplification we get 550 plus 350 rupees. So it amounts to 900 rupees. This is the total annual bill of the consumer for consuming 9750 units. Now let us calculate what is flat rate of unit. So this is the annual bill, and we know what is how many units are consumed per annum, that is 9750. Substitute this annual bill divided by number of units generated. So that is 900 divided by 9750. Then after simplification we get the value as 0.0923 rupees per unit, or that can be written as 9.23 pies.